So the first one we are going to graph by using a table. Please, when you make your table, I want you to have a minimum of 5 points. If you would like to have more than that, you are welcome to. But 5 is going to be the minimum. Anytime it tells you a specific way to graph, you are going to have to use that. So graph by using a table. The first thing we want to do is make sure that this is in standard form for a linear function, which what is that? This y equals mx plus b. So that's going to be the first thing. Okay, put in y equals mx plus b form. And this one is actually very simple to put it in that form. It's just y is on the wrong side, so you always want y on this left side here. So we can just rewrite it as y equals 4x minus 2. Okay, if they're just on the opposite sides, you can just flip them. That's fine. And then our second step is going to be to make the table with 5 points. Again, you can choose any 5 points, but I do want you to span the grid. So I am going to be giving you graph paper today, and I will be giving you some graphs. They won't be labeled like this. I'm going to let you label them so you can change your scale if you want to. And when I say span the grid, it just means wherever your points are, we have to make sure that we have those, okay? Oh, and then I am going to let you use some straight edges today. Some of you may have already found them, but we need to use them responsibly. I know they are fun, and then sometimes people like to put them on their pencils and whip them around. We're not going to do that today, okay? So if you don't have one, I am going to come around and give you one. You can use any straight edge. I like these. These are actually compasses. So when you are making a table with 5 points, like I said, you can pick any 5 points. If it's linear, sometimes I will start with 0 to see what happens in the middle of the graph. So if x is 0, do you guys know what y is right away? How do you know it so fast? Yeah, this is the y-intercept, right? Anytime you have the x is 0, the y-intercept is your value of b. It's right there, okay? All right, let's try plugging in 1. How am I going to find the y if my x is 1? You could do that. You could also just do what with your table? Yeah, just plug it in, right? So 4 times 1 minus 2. 4 times 1 is 4. 4 minus 2 is 2. Okay? And then at 2, 4 times 2, 8. 8 minus 2, 6. Okay, and then I'm going to try 3 as well. 4 times 3 is 12. 12 minus 2. Okay, and then that will take me to the end. So now I'm going to go on the negative side, and I'll just pick some from there. So negative 1. And then when you're doing this on your homework, I know that some of these you can do in your head. I'm not going to require you to write all those out. Like the workout, you can do 4 times negative 1 minus 2 in your head, I know. Okay, but if you like doing that because that helps keep you organized, that is fine too. Okay, so 4 times negative 2 is negative 8. Negative 8 minus 2, negative 10. Okay, so I did a little more than 5 points. I wanted to make sure I had that. Okay, that is fine. Then you're just going to plot your points. So I have negative 2, negative 10, negative 1, negative 6, 0, negative 2, 1, 2, 2, 6, 3, 10, and then you'll connect those with your straight edge. And then when you are drawing a line, what do we want to make sure we have on both the top and the bottom? Arrows. Arrows, perfect. Your geometry teacher will be proud. Okay, and then once you have finished that one, go on to number 2. Yes. So I want you to do it, the first step where you're plugging it in, or sorry, where you're putting it in y equals mx plus b form.
Oh, that was my big Snapchat birthday. I set it on by accident.
What's your real birthday?
March 23rd.
Who was the first one to post it?
Huh?
Who's the first one that started it, that posted it?
Some idiot that had a Snapchat.
Let's not call people names. You're the one that put that's your birthday.
I didn't put it there. It was just, it's the day I signed up for Snapchat.
Oh. Alright, and then, like I said, what I want you to do is I want you to put it in the form y equals mx plus b.
Happy late birthday.
That's you.
Happy late birthday.
Yeah, is it late or early?
Wait,
Happy almost half birthday.
I honestly do.
Okay, so for b, y plus 3x equals 1. How many of you have already solved this for y? Some of you look scared that you already solved it for y. Okay, so how did we solve this? Morgan, can you tell me what you did?
I moved the 3x to the other side.
By?
Subtracted.
Yep, so minus 3x minus 3x. Okay, so make sure that you do the proper operation. Don't just say the 3x plus 1. Okay, you have to use addition or subtraction to move that across. And so this is our equation. Okay, now we can do our table. I'm going to let you do that. Okay, so it just has to be at least 5 points. And like I said, it should stay in the grid. Do you guys remember what number I started with last time? 0. I like to start in the middle. I like to see where this train is going. And then just start plugging some in your head, right? So if you plug in 1, negative 3 times 1, negative 3, negative 3 plus 1, negative 2. That number's kind of small, so maybe I would jump up and try 3 next time. Okay, so I want you to pick 5 points and then go ahead and graph them. Alright, will you guys check yours with me? So the first thing I do when I do these, I do a quick check. What that means is I look at the slope. So the slope here is 4. That's positive, so this should be going up from right to left. What about this one? What about number 2? Where should your graph be headed? Should be going down from left to right. Did I say from right to left in the other one? Yeah, from left to right. Okay, so here are the points I chose. Again, you do not have to choose the exact same points. Okay, any 5 are fine, and as long as you have the graph span, that's fine. Like I said, I like to start with my y-intercept. Okay, so at 0, 1, here I am, and then negative 3, I'm at 10, negative 1, I'm at 4. Okay, and then connect with your straight edge. Alright, so anytime you have to do it with a table, all I need to see is your table with your 5 points, and then of course your graph. Okay, and then for example 2, for this one you have to graph it using the x and the y intercepts. Okay, so what you're going to do is you are going to plug in a value. So for every x-intercept, okay, an x-intercept has the form x0, a y-intercept has the form 0y. So for every x-intercept, the y value is what? 0. So to find the x-intercept, you're going to plug in y equals 0 and solve for x. Okay, so if I plug in y is 0, I have 0 minus x equals negative 3. What's 0 minus x? No, what's 0 minus x? If I were to simplify that, negative x. And then I have negative x equals negative 3. Okay, and then a lot of you know if this is opposite, this is opposite. The algebraic step is to divide by negative 1. Okay? Alright, and then we're going to do something similar with the y-intercept. Okay, so to find the y-intercept, you have to plug in x is 0 and solve for y. Again, this is something that you've done before. All we have to do is substitute. So y minus 0 equals negative 3, y equals negative 3. Okay, so I just want to see your steps with algebra. Once you have done that, you are going to plot those 2 points and connect with a straight edge. Plot intercepts. So again, I want you to span that grid. Will you leave that slightly ajar because I'm going to have a couple people coming in. Just leave that slightly open for me. Thank you. Okay, so x equals 3, so that's going to go here. Y is negative 3. So when I say span the grid, I mean you're just going to show me, you're going to connect those 2 points, okay? And I want it to span the grid like this, okay? And that's why we're using our straight edge so we have a more accurate depiction. Alright, and then you guys can flip it to the back. And then we are going to be graphing now with, like, do not touch my thermostat. I have to be in here all day. Okay, so for this you have the negative 3 and the 3. We're connecting those. On the back, we are going to be using M and B. So we already talked about this a little bit today. Your M is your slope. Your B is your y-intercept. Okay, so when you are graphing that, you have to start at which point? At the y-intercept, not 0, 0. Okay, so you always start at your y-intercept, which is your B value. Okay, so for this one, you're going to start at 0, 12. But if you look at your graph, you really don't have 12 on the graph. So in that case, if you want to extend your graph, you can do that, like 11, 12, that's fine. Okay, so if not on the grid, you can extend graph. Or you can change the scale. Like I said, for your homework, I'm giving you blank graphs, so you can make the scale whatever you want it to be, okay? So if you want to scale by 2s, you could do that. Okay, but if you are changing the scale, just make sure you write that down. Alright, now earlier I asked you guys what you knew about linear functions, and one of you said the rise over the run. That is how we're going to find our next point. So for step 2, you're going to use your slope. Okay, which is the rise over the run. What does the rise mean? What does that refer to? Yeah, you're up or down. Good. I always think like rise up goes together. And then the run is going to be the right and the left. Okay, it's like you can't run up a wall that's straight up and down, right? Even American Ninja Warrior has a little curve when they're running up there, right? Okay, so you're running horizontally, you're rising up or down. All right, now this one, your slope is -5/3. So when you have the negative, I always put it on the top. So -5/3. So we're going to go down 5, we're going to go right 3. You could also do the opposite. You could go up 5, and then you could go left 3. That would be fine as well. Alright, so if we start from the 12, which we extended here, we can just start counting down. 1, 2, 3, 4, 5, 1, 2, 3. And then you just continue that pattern. 1, 2, 3, 4, 5, 1, 2, 3. Okay, and then once you span that part of the graph, just go ahead and connect those. And then make sure you put your arrows on them. Okay, so we're going to use that in our next example as well. So when you're graphing inequalities, you really are going to start by graphing those lines. So you have what's called a boundary line and then a shaded region. The boundary line can either be solid or dashed. I think some of you, did some of you talk about like the boundary line is open or closed? Does that ring a bell from earlier years? Okay, so if it's the open, it's going to be the dashed line. If it's closed, it'll be solid. Okay, so if it's the solid closed, that's when you have the equal to symbols. Okay, and then the dash line is when you just have the greater than or less than. So greater than or less than. So it always depends on what symbol you have. Can any of you tell me why inequalities have shaded regions and just the linear equations don't? So why doesn't inequality, why do we have to shade somewhere?
The shading represents all of the values that fit the definitions.
Yes, okay, so when you have an inequality, there's more than one value, right? So let's talk about like a simple one. Something like x equals 4. For something like this, x can only be 4. It can't be anything else, right? But if you had x is greater than or equal to 4, how many numbers would fit that? An infinite amount. That's why we're shading above or below the line for these, okay? So in order to check where to shade, we're going to be using what is called a test point. And if you can use the test point 0, 0, that is the simplest one to evaluate. And then what we have to do is see whether the statement is true or false. Okay, so we'll be writing that out. Now, if it is true, okay, if your inequality is true, you are going to shade that region. But if it is false, we are going to shade the opposite region. Okay, and we'll practice that. So this process I really break down into a few steps, okay? And 1 and 2 are really interchangeable. The first thing I like to do is get it in y equals mx plus b form. Okay, and then I decide if the line, I'm going to graph the line, and then I decide if it's dashed or shaded, or sorry, dashed or solid. So get it in the proper form, and then to graph the line, figure out if it's dashed or solid. And then the last thing I do is use the test point, and then shade. Okay, so again, you're going to use 0, 0 unless the line goes through that point. Okay, so if it's on the boundary line, if 0, 0 is on the boundary line, okay, you can't use that point. You can use any other point that is not on the boundary line. Okay, most of the time you are going to be able to use 0, 0. Okay? Alright, so let's do this part together. The first thing I'm going to do is put it in y equals mx plus b form. So I have y minus 7 is less than or equal to negative 9. So what can I do to get y by itself here? Great. Okay, so if I do that, then I have y is less than or equal to negative 2. This is in the form y equals mx plus b, even though there's no x term. If there's no x term, do you guys know what your slope is? It's not 1. 0. Okay, so if there's no x, it'll be 0. Do you guys know what type of line this is if you have y equals? It's going to be solid, but there's another special term for it. Yes, if you have y equals or an inequality, it's a horizontal line. And then you'll have a vertical line if you have x equals. Okay? So those are going to pop up. And actually, I think those are the simpler ones, is when you have either y equals or the x equals. Okay, so you guys already told me it was a solid line. So you are going to graph the solid line at y equals negative 2. Do you guys know how to graph that line? Yeah. Okay. Okay, so if I go to negative 2, remember, we just said it's a horizontal line, so it's just going to be like this. Horizontal and solid. Okay? Now, with ones that are vertical or horizontal, you know where to shade, like without even doing your test point, but we're going to practice that process here. Okay? So the test point is 0, 0. Every point is in the form x, y. So what this means is we plug in 0 for x and y into your equation. And you can really use the original equation or your simplified one. I would use the simplified one. Okay, so you're going to plug this into your inequality. Okay, so 0 is less than or equal to negative 2. Sorry, I guess I should put this is what we're plugging it into. So instead of y, I have 0. Negative 2 stays the same because I don't have anything else to plug into. It's okay. This one doesn't have an x, so you don't have to plug it in. What you do have to do is tell me if this is true or false. So 0 is less than or equal to negative 2. True or false? So this is saying negative 2 is bigger than 0. False. Okay, so if it's false, we put a slash through it, like this, and then we're going to say false. If it is false, do not shade your test point. So do not shade 0, 0. Okay, so is 0, 0 above this line or below it? Above. Okay, so if it's above and I don't want to shade it, I'm going to shade everything below it. Okay, and then you just have to, again, just scan whatever grid you have. Alright, there you go. So like I said, with ones like this, it's less than, so you know it is below. Okay, but for your other ones, I absolutely, well, I want your test point anyway. Okay? Alright, now we are going to do B. Okay, so again, the first thing we're going to do is we're going to write that in the form y equals mx plus b. And then I'll give you guys a second to do that. Okay, so I want you to do the first step. We'll talk about the second step because there's something special that happens and I want to see if you remember how to do that. Oh, perfect. Okay, so then I'll give you this. And then I'll add the two equals Alright, so what do we do first? Yeah, so we're trying to get y by itself. You move the y over there? No, y is going to stay on the left.
You move the X.
Yeah, let's move the x. I'll show you how to do the other way too. But I do want you to know how to do it like this as well. So this is negative y is greater than negative x minus 4. Okay, and then how do I make that y positive? Yep, you can multiply or divide by negative 1. So then this becomes y, and what happens? The sign will flip. Good. Okay, so whenever you multiply or divide by a negative, when you have an inequality, there's that special rule that's so easy to forget about, right? The rule is you have to switch the sign if you divide or multiply by a negative. Okay, so switch the sign. So this is what we are graphing here. Okay? Is this going to be a solid line or a dash line? Dash. Okay, so when we're graphing this, start at your y-intercept. What's your y-intercept? 4. What's your slope? 1 over 1, or 1. So if I start at 4, and I go up 1 over 1, if I do that, really you can just put your dashes in here, okay? So our arrow, and then we can go back, down 1 to the left, down 1 to the left, down, if it's the 1, that's pretty simple to do. Okay. And then I told you that I'd show you the other way. So some of you said, oh, I moved the y over. That's fine. So if some of you added the y like this, you'd have x is greater than y minus 4. And then you added the 4 like that. Right? Is that what some of you did or no? So when you rewrite it, just make sure you keep the sign pointed at the y. Either way, you'll get this. I don't care what way you do it as long as you show me what you did, okay? Okay, so y is less than x plus 4. Alright, what questions do we have about this step so far? This step's good? Alright, let's do the test point then. So test point 0, 0. So we're plugging this in for x and y. Again, I would just use this one that you solved. Okay, so if I plug in 0 for x and 0 for y, I get 0 is less than 4. Is that true or false? Yes. Okay, so if it's true, just write true next to it, okay? And then find 0, 0. So if it's true, you are going to shade 0, 0. Okay, so true, you're going to shade 0, 0. So that means I'm going to shade below it, so that my solution includes the 0, 0. I'm going to shade everything below it. Alright, and then I had a good question last hour. They said, oh, is it always going to be below the line? No. So it is going to vary depending on where it is. Do you see how this one was true and it was below? This one was false and it was below? So you can't say if it's true, you're always shading below. Or if it's false, you're always shading below. Okay? It's going to change depending on where your line is, okay, in relation to 0, 0. When you are doing this on your homework, what I'm looking for is I'm looking for this equation and you telling me whether it's true or false. Okay? So I need to see that part of it. Alright? Okay, so, like I said, I'm going to give you guys a graph sheet. Okay, and then your homework. This is in the textbook, page 33. And if you want to do, you can do all your work on the graph sheet that I'm going to give you. There is some space to write work. Okay, so 1 through 3, number 8, 11, 12, 14 through 18 are just the evens. 19 through 29 are the odds, and you can skip number 25. Okay, and then I'm going to pass out your graph sheets. So again, if you use a scale other than a 1, just tell me what you're scaling by. If you will both. If you do work up in your notebook, then you're going to show me. Then you can take a picture of that. Yeah. Yeah, make sure that wherever you're working, you're turning that in with you.
Are we going to need to write stuff for the homework?
Nope, you're going to, because you got to have your table. Really, the only ones you won't have to write anything for are the ones where you're graphing with y, so then it's going to be. Yeah, so be very vigilant. I'll remove that away, okay. And then I know some of you missed the first thing, your NWEA, so I'm gonna put that up for you. Oh, it's yellow one. Oh, there. Oh, there, yes. Whoop. Hi. Yes, I will. Thanks. Bye. Joseph, you are being summoned to the office with your thief.